With that, I'll turn it over to Austin.
This is the agenda. We're going to talk a little bit about the background, sort of continuing from Jeff's discussion of the background of the background. What it is to use tools, what's the context in which we're talking, then a little bit about conceptual model basics, how we see conceptual models playing in the role of development, a little bit of an exercise, get you to work, touch on some advanced topics, and then talk a little bit about the benefits of this, and then take questions. Now, in many ways, I think both Jeff and I regard this as an extremely old and boring topic, because you must all know about conceptual models. But what led to this book and what came before it, which was an article in 2002, was some appearances of conceptual models in some of Jeff's books, and a discussion which he and I had at one of the BayCHI conferences, I guess it must have been 2001, saying, how come we don't hear about the conceptual model when you're building an application? How come what we hear is about buttons and interfaces and all of that, but we don't hear what's the concept that this application is delivering? And so we were moaning to each other about it. We said, well, why don't we write it? So we wrote an article in Interactions magazine and put it out there, and it had significantly little effect, as best we could tell. So encouraged by that, what we did was say, look, we're going to have to take a bigger run at the thing. And every now and then somebody would come up to us and say, I really like that article. You know, it's really been helpful. So we thought, okay, we'll do it. And so we took a crack in writing this book, which is about the core of good design. It's an ebook. It's also in paper. But throughout all of this, Jeff, particularly me to a certain extent, have been giving tutorials on this subject matter wherever anybody can be persuaded to listen, and preferably pay for it, right? So that's kind of where it's come from. What we want to do is make sure, though, that we're on the same page here. So here's and please interrupt at any time you want. Here's the, and you too, if you want to jump in. Here's the context out of which we're talking, right? That you've got a user who's trying to get a task done, and it's in some sort of task domain, and they have available to them an application, your application, the thing you're designing, and all sorts of other stuff. So if I'm building a copier, good thing to do here in this building. I was here for 16 years. That's what we did. You might have also tables and staplers and other things like that. But the goal of the exercise is to make 22-sided copies for that meeting you're about to go to. That's the task, and what you have to do is you, user, have to put together a plan for how the heck you're going to get that done with this stuff. And this stuff is composed of a bunch of concepts, a conceptual model, okay? And then some sort of presentation of that sort of stuff, and then all sorts of implementation details having to do with documentation, help scripts, code, schedule for getting the job done, all of that sort of stuff, which is sort of down in the grubby real world of getting it done, all right? Which will come back again. So here you are, user, with some model in your head, the mental model of all of this stuff, right? And as Tom Moran showed early on in trying to pull out of people their conceptual models, the mental models that users had were all over the place. Wrong, ambiguous, shifting. We're not really talking about mental models here, except that the easier it is for a user to form a mental model which is sort of close to the ideal conceptual model, the better it's going to be. So our job then is this. This is us. We're trying to build a conceptual model of that, right? What we're trying to do is say, what ideally is the model that a user would have of this? What will help them build plans of this kind, which will make it possible for them to work over that domain, right? So that's just putting the terms that we're going to use on the board. Jeff?
And I'll just add to it a little. Oh, I don't have a mic. I have a mic there? Yeah, I might. So, and I'll just add to it by saying that.
Stand.
I'll just add to it quickly by saying that, so how many of you have heard the term task domain before? How many of you have not heard the term before? Okay, so a task is something like producing a quarterly financial report. And a task domain is accounting. Or another task is, sinking a putt in golf. And the task domain is the game of golf. Okay, so a task domain contains many tasks. And a task is one of the tasks in that. And so the task domain of accounting, or there's the task domain of accounting, the task domain of playing golf, the task domain. So I just wanted to make sure that you understand that terminology.
While you're on your feet, continue.
Oh, continue. Thanks. Okay. So conceptual design, just to give you some basics, is you can consider an application. An application has concepts and it has presentation. And the important thing is that the concepts affect the architecture of the application. So if you change to the conceptual structure, or you change the relationship between concepts, that will change the architecture of the application. So it's very important when you're designing an application to consider its concepts first and how they're connected and related to each other, and then worry about the presentation. So that contradicts what people often think of as user interface design, because they often say, when are you going to draw us those wireframes? When are we going to get the wireframes? Or when do I know where the buttons are going to be? What color are the buttons going to be? Are the menus going to have 10 items or 15 items? And we go, no. We need to know first, what is this application? What is it? Before we design how it looks or how users operate it. I'm constantly telling people, no, we're not going to jump right into sketching the user interface. We're not going to. Sorry, if you were hiring me to do that, hire somebody else. Okay? We're going to get there, and in fact, we'll be better off once we know what the application is. So the conceptual model, as Austin said earlier, is the designer's ideal structure of concepts and how they're related to each other. So it's an organization structure of concepts. It's the intended user model. Now, you have no direct control over what the actual user models are, but you can push for a particular user model or mental model by designing a clear conceptual model and then basing user interface on that. So the goals for your conceptual model are less is more. We're in California, so we can say less is more, right? Our governor says it all the time. So, and also your conceptual model has a goal of being focused on the task domain. And we'll see here in a minute what that means. There are certain things that focusing the conceptual model on the task domain excludes. We'll talk about that in a minute. So an important component of building a conceptual model is performing what's called object operations analysis. So objects are objects are exposed to users. An object operation analysis is composed of objects that are exposed to users, attributes of each object type, operations on each object type, and relationships between objects. For example, one kind of relationship is, what is a subtype of what? So for example, a checking account is a kind of bank account. A Prius is a kind of car. Okay, so that's a subtype. And then there's what is a part of what. So for example, a wheel is a part of a car, and a disk. Well, I was going to say a disk is a part of a computer, but actually this computer has no disk. So go figure. And then there's what can contain what. So for example, a bus contains passengers. An email folder contains email messages. So these are three common relationships, but there are others. Your application may have specific kinds of relationships. So for example, Facebook has a relationship of friend between two different users. So here's an example of a conceptual model, or if you will, an object operations analysis for managing a bank account. So you've got the objects over here, which are customers, accounts, debit cards, transactions, and checks. The attributes on customer are things like names, address, phone number, and age. The operations on customer are things like register, unregister, add account, view, and edit the attributes. An account has an owner, a customer, or a customer, a balance, currency, interest rate, et cetera, et cetera. A debit card has these attributes, a transaction has these attributes, a check has these attributes, and these are the things that you can do to each of those things. And it's important when you're doing this to make sure that the operations and the attributes are on the correct object. That's one of the things that makes creating these conceptual models hard. And we found in our experience teaching this that people who've done object analysis of software design generally have a better handle on it and are able to more correctly assign, or more usefully assign attributes and operations to objects. However, those same people also have a tendency to let implementation objects leak into the user interface, so there has to be some break on them. Somebody on the team who's not an implementer, in order to keep non-user, non-task-oriented objects out of the conceptual model. So for example, in managing a bank account, you would not want to have objects like database, dialog box, mode, and string, because those are not objects in the domain of managing a checking account or a bank account. Those are objects in the domain of operating a computer or programming a computer. And that's not what the user is trying to do. The user is trying to operate a bank or manage a bank account. The task domain is managing bank accounts. The task domain is not operating a computer. So these are foreign objects. They should not be in the conceptual model, even if they are in the object model of the programmers. Does that make sense? Okay. And so maybe, just maybe, you will need concepts in the conceptual model like a template for, let's say, repeated transactions. I have a bank account, and every month I have to pay my rent. So maybe I need a template so that I can do the same transaction every month. Or maybe not. Maybe I don't need it. Maybe I can get away with not adding that concept to the conceptual model. Or maybe every day when I come to sit down at my bank account application, I know I'm going to fire off the same 10 commands in sequence, or the same 10 operations in sequence. So maybe there has to be a concept of a stored command sequence, or as programmers would call it, a macro. Or maybe not, because maybe if you add that concept to the conceptual model, it will make it too complicated for many of your intended users. So the question that you're always facing as a designer is, how do you keep it simple, focused on the task domain, but provide the functionality that most of your users are going to need? Okay? And people often say to me, well, we do need to add this concept because we're making their application more powerful than the old paper checkbooks that they used to use. So we're adding concepts that they're not familiar with. So there are going to have to be concepts that they're going to have to learn. And we're just adding 2 more concepts, so what's the big deal? Well, the big deal, as many of you in this room I'm sure know, is that adding concepts to an application does not result in a linear increase in complexity. As you add concepts to an application, the complexity goes up multiplicatively because every concept interacts with every other concept that's in the application, and the complexity of the application grows much faster than linearly with the number of concepts that you add, okay? So when you're thinking about adding concepts to the conceptual model for an application, do that with what I call resistance. Do it with resistance. You can do it, but there has to be a good reason. So managing a bank account there shouldn't be no, a transaction can have all the attributes we named earlier in that table, but it shouldn't have a memory size or an export encoding, because again, those are not attributes of transactions in the task domain of managing a bank account. They are attributes in the domain of operating a computer. And similarly, what operations should be on, well, you shouldn't have operations like click button, load database, edit table row, create record, flush buffer, because again, those have nothing to do with managing a bank account. Again, they're operations on a computer. And again, as I said earlier, maybe you need operations like create template and save command sequence, but maybe you can get away without it. And if you can, so much the better. Then we have relationships. How are objects related? So for example, in our task domain of managing a bank account, you have customers and they own accounts. So the relationship between a customer and an account is one of ownership. And then there's savings account is a type of account. And transaction changes the account amount. Okay, so the amount in an account, the balance in an account will change before and after a transaction. And transactions can occur by check, debit card. This shows you how old I am. Mm-hmm. Nobody uses these anymore. So a bank teller, not a bank teller, but a grocery checker told me recently that only old people use checks anymore. And I was writing her a check at that point. So I'm trying to get away from using checks. So, here are the overall benefits of designing a conceptual model before you design the user interface, which it declares what is and isn't exposed to users. I think of a conceptual model once you have it and have captured it in some kind of a document, and we'll talk later about what kind of documents they can be. I consider that to be a contract. Once the team, not one person, or sometimes it's the architect, but once the team has a conceptual model, nobody gets to add new concepts on their own. So you're going to have every team should have an architect or somebody who's saying, Fred, there's a concept in your part of the application that wasn't in our conceptual model. It should not be there. We didn't agree on that. Okay? So that's one of the things, that's one of the benefits, is that it declares what is and isn't exposed to users, which makes it actually easier for a user interface designer. It's also a basis for high-level task scenarios, and I'll give you an example of that in a minute. It's a basis for the product vocabulary. We'll talk about that in a minute too. So all I'll say about this is that if you got the objects that users are exposed to, the attributes on those objects, and the operations on those objects, you probably have come up with at least some tentative names for those things. And that gives you a first cut at a vocabulary. What are we going to call everything in this application? And that vocabulary is going to be very useful later because it's going to help the documenters, it's going to help the people who are going to be writing the messages, the error messages and the instructions. that'll appear in the application. I'm going to open one of these. And it provides a clear target for designing the rest of the user interface. So the user interface designer is now the person whose job it is to create those wireframes now has a much easier job than just sitting around and blue skying, what are all the different many possibilities. The set of possibilities has now been constrained by the existence of a set of objects, operations, and attributes and relationships. And furthermore, the user interface designer can see object relationships that they wouldn't have been able to see otherwise, which allows simplification. Oh, wow, a bank account, a checking account is actually similar to a savings account in many respects. Gee, maybe when someone creates a checking account, the operation for creating a savings account should be essentially the same, right? So, and this is the part that managers really like, because up to this point, basically these are benefits that people in the development team can see, but managers will say to me, so you want to do this conceptual model thing? I've never heard of that before. How long is that going to take? And I'll say, couple of weeks. Couple of weeks? I got 27 programmers sitting on their thumbs in Russia waiting to code. I'm not going to, no, they're not going to sit around waiting for us to do that. Before we do the wireframes, I want wireframes tomorrow, okay? And what I tell them is, look, once we do this, we're going to move a lot faster than we would have moved. If we don't do this, we're going to spin our wheels a lot. We're going to throw away a lot of code. We're going to throw away a lot of wireframes. We're going to go through all sorts of iterations that we wouldn't go through if we did this, sat down and figured out what this application is and what its parts are and how they're related to each other. And so that managers actually like that. And the other thing that they like a lot is, think about it this way. Once you have the objects, operations, attributes, relationships, the programmers can start to code. They don't need any wireframes yet. How is this going to be presented? Is it going to work by phone? Is it going to work by iPad? Is it going to work on an iPhone? They don't care. They just start implementing the objects, the operations, the attributes, and then meanwhile, the user interface people can be, spending all-nighters trying to get the user interface design built that reflects into the world the user interface or the app functionality that's reflected in the or that's implicit in the operations and attributes. Okay, so managers love that because they don't have to wait for those wireframes before their programmers can start coding. And finally, it facilitates documentation, training, and support. And overall, and again, this is what managers like, it saves time and money. You'll go a lot faster if you've thought this stuff through, because your iteration, a large part of your iteration is going to occur at the conceptual model stage and not at the prototype stage. Okay, so I mentioned a whole bunch of things, and I'm going to go back and talk about a few of them in more detail now, and then I'm going to hand it off to Austin. Conceptual vocabulary, I mentioned that one. That's one of the benefits of doing a conceptual model. When you are designing an application, one of your goals is to have terms mapped one-to-one onto concepts. How many of you have seen an application in which something was, one concept had one name on one part of the application and a different name in a different part of the application? And I'm sure everyone in this room realizes, because we're all HCI folks, that has a profound impact on the learnability of the application for new users, okay? And so Carolyn Jarrett, who was a colleague of ours, who's in the UK, came up with this great phrase: same word, same thing, different word, different thing. That's your goal. Do not have, and you need to have, one-to-one mapping between terms and concepts. And you're not going to do that unless you've actually sat down and figured out what your terms, your concepts are and what your terms for them are going to be. The software and the documentation and everything should conform to that vocabulary. So you won't get a situation like I had just last week where I had an electronic device, I took it out of the box, and I had to register it online, and it turned out that they were asking for the product code, and on the back of the thing it didn't have a product code, it had some other kind of number called something else. And I wasn't sure if that was the product code or not, okay? Because they called it one thing in one place and a different thing in a different place. Somebody on your team needs to protect that vocabulary. They don't necessarily have to be, you don't have to have a dictator who decides what the vocabulary is going to be. The team will decide that, but once you've done that, somebody has to be on your team to go say, Bill, we called it a widget in that window, and we call it a gadget in that window. Only a widget is in our conceptual model, so is this gadget a different concept, or is it just a different name for the same thing? Because our vocabulary says it's a widget, okay? And then you have conceptual scenarios, comes out of this conceptual model thing. Because once you have the concepts and their relationships and their attributes, you can build stories of users doing tasks. And in Agile, we call these essential use cases, and I'll explain how that works in a second. But the important thing is that these are expressed at the conceptual level, using terms from the vocabulary that you've created. You have created a vocabulary, right? Okay. They're not at these scenarios and stories are not at the keystroke or GUI level because you don't have a GUI yet. You don't have a website yet. You don't even know if it's going to be a website. Okay. So here's an example of a conceptual scenario. I'll read it to you very quickly. Sally needs to update addresses in her address book. She opens the app, finds the entry for her friends who moved across town, opens it for editing, edits it, reviews it for accuracy, and saves it. Another family she knows got rid of their landline, so she edits their entry to delete that phone number. Similarly, she edits 3 entries for friends who recently moved, merges entries for 2 friends who got married and now live together, and separates an entry for 2 other friends who split up. While doing all this, Sally notices entries she no longer needs as her entry book and her address book and deletes them. After making sure her updated address book will be synchronized across various devices, mobile phone, tablet computer, laptop computer, and desktop computer, she quits the app. Okay, notice there's no presentation in this. There are no buttons. There are no sliders. There are no windows. We don't even know if she's done it by calling up a phone tree or by touching her iPad. We don't know. We don't care at this point. Okay? But the other important thing is that this constrains what the application can do by quite a lot. Then you can break this up into what we call in Agile use cases. And you can write each one on a card and give it to a programmer or a programming team. Implement that. Okay? So if you don't do a conceptual model before you start to design your application, design the user interface of your application, you will end up with these things that we've all seen many times in applications that we're using constantly day by day, and also ones that our own teams have developed. And also, these are all bloopers that are documented in my bloopers books, web bloopers and GUI bloopers, which are out there on the table, okay? So, for example, inappropriate concepts that are off task, or that are based on implementation, or that are concepts that have to do with presentation and interaction. In fact, I was just using an application, I just got a new Samsung camera the other day, and I was looking at its little quick start manual. And the quick start manual has sections in it like how to use the such and such button. It's like how to use the menu button. I don't want to use the menu button. That's a user interface concept. I want to delete pictures, or I want to make the pictures brighter, or those are use cases. Using the delete button is not a use case. based on presentation and interaction. So here's the kind of bloopers you can get. At iCasualties.org, which we won't get into politics here because that could be dangerous, but this website lists the Iraq Coalition casualty count, okay? And it starts you out by saying, please select database. Wait, I didn't know Iraq was a database. I didn't know Afghanistan was a database. It should be something like, please select war zone. So the terminology there is not task-oriented. Here's another example. I was actually helping a client develop software for stockbrokers. And stockbrokers, there's one thing that happens with stockbrokers is if your job involves sitting at a desk, waiting for people to call you and say, I want to buy 30 shares of Apple, one of the things that happens is stockbrokers know that transactions in the stock world tend to happen in runs. So I know that if 5 people start calling me and say, I want to buy 30 shares of Apple, then I'm going to get a lot of calls to buy shares of Apple over the next several days. So one of the things that stockbrokers want in an application is a way to not have to key in the details of those things every time with every new customer. So they want to be able to create templates for transactions that they think are going to occur over and over and over in the near future. And it turned out that there were 2 kinds of templates that this application could create. Ones that you, the stockbroker, were going to use, and one that were going to be shared by everyone in your office. But the developers had already called these things create local template and create database template. Why? Because these templates were stored on your computer. And these were stored on a database server somewhere in West Virginia. Okay? So that's what they were called, and people had no idea what those terms meant or anything. Those were not task-related terms. So we ended up changing these to create private template and create shared template, because that's what they were as far as users were concerned. Now, there are users, namely the people who maintain the system, who need to know where they are. But that's not the stockbrokers. That's the system administrators. They get a different user interface, okay? So we have inappropriate concepts, and then we have confusable concepts. So for example, on Macintoshes, confusable concepts is actually one of the bloopers in my GUI bloopers book, which is concepts that are so close to each other in functionality or in the user's mental model that the users are going to think they're the same thing. How many of you have seen applications that had that kind of thing going on? So for one of the examples that I like to use is on a Macintosh, Mac OS. You want to write a note to yourself and stick it somewhere? So there are stickies in the desktop. There's a sticky application that comes with Mac OS. Oh, and there's also a notes application on the desktop. So are you going to write your note on a sticky, or are you going to write it on the note? Well, that means that tomorrow you're going to think, where did I write that note? Okay, which one of those did I put it on? And not only that, and by the way, this is one of the things that's confused my wife many times, is she's written a note down somewhere, and then the next day she says, I know I wrote this note to myself, but I can't find it. Well, she wrote it in the wrong sticky note, because not only are there on the desktop in Macs these yellow stickies and these notes, but there's also a dashboard. Well, before we get to that, let me just say, so here's an example of the launcher in the Mac OS, and there's your to-do list, there's your notes pad, and there are your yellow sticky notes. Which one did you write the stuff to do in? But if that's not confusing enough, there's also a dashboard in Mac OS. How many of you are familiar with the dashboard? It's sort of off the desktop, and it has its own yellow sticky notes app, separate from the yellow sticky notes on your desktop. So if you wrote something in the yellow sticky notes in your dashboard, it's not going to be in the yellow sticky notes on your desktop. But you have to remember where you wrote it. So much for the user-friendliness of the Mac. And then finally, in terms of bloopers, we have ambiguous terminology, which, as I was saying earlier, remember Carol and Jarrett's phrase, same word, same thing, different word, different thing? You can violate that rule in two different ways. Different terms for the same concept, same term for different concepts. So here's an example of the first one, citycarshare.org, and a website I use a lot, okay? The username and password you enter do not match, member ID, password. What? So we're all geeks in this room, right? So we just go, oh, somehow this used to be called username, and somebody changed it. User interface designer decided that wasn't user friendly enough, so they changed it to member ID, but they forgot to change the error message. Or maybe it was the other way around. Maybe they changed the error message and they forgot to change the label. Or maybe this message is generated in software from the name of this object, the name of this field, which is username. You know, there are many ways in which this blooper could have come about, but it has come about. And what's that going to do? To us, it's going to go, oh, that's stupid. To my grandmother, it's going to stop her in her tracks. Yeah?
Doesn't it bother you that the concept of match is connected to anything?
Sorry?
The wording there. That's what first grade is reading.
Right. Right. Well, so that's another thing is that, so my grandmother might respond to that by typing Fred Flintstone in here too. Here's the opposite problem, the same term for different concepts. How many of you have a blog in WordPress? So if you're an administrator of your blog, you'll have to get to your dashboard, which is where you control all the management aspects of it. But if you go to your dashboard, one of the things you'll find out is that in the dashboard there are many pages, one of which is the dashboard. Well, how could that have come about? Well, you know, there are lots of theories about it. I mean, one is that there used to be only one dashboard page, and so this was only one page and not a bunch of pages, and they kept adding stuff. Eventually, they had to split it out into different pages, and they couldn't think of a name for the first one, so they continued to call it the dashboard. But it doesn't matter how it came about. Just imagine the problem that a documenter is going to have in writing that into a manual. Well, you go to the dashboard, and then you get to the dashboard of the dashboard. Okay, so again, one concept, one term. That's the way it should be. This is two different concepts, one term. Or programmers would call it overloading terminology. And often, you know, when you point out either this problem or this problem to developers on a team, their response is going to be, look, I have more important things to do than to figure out the right terminology for all of this stuff. Somebody else is going to figure that out down the line. My job is to make sure the code doesn't break. Okay? And in a certain extent, they're right. Somebody on the team needs to be in charge of making sure that the vocabulary is consistent. And maybe it isn't the programmers because they weren't trained in English language. In fact, maybe they don't even speak English as a first language. But often, too often, there is no one on the team downstream that has the job of making it happen. And it goes out into the world like this, okay? All right.
So as usual, I think Jeff's gone off the deep end. You can't really do all of the conceptual model and then get to these other things later. Because in fact, a lot of those conceptual models already exist. You've got legacy apps out there, and you're dealing with something, as Jeff pointed out, which is going on through time. And so this is a very self-serving picture around the way we see the conceptual model as being the responsibility of everybody on the team, all the way from the users who are talking to support, who may in fact then be interacting with this. And if in the process Perhaps you're working your way around this way and building things. If in the implementation you suddenly discover it's becoming very expensive to do what had been figured out, you sort of say, well, we can't do that. Well, if you're going to say that, then what you have to do is ideally come back to the conceptual model, come back to the team who's sitting around a table, logically or actually, arguing it, and to say, we're proposing to make this change. And the screams you get from everybody else and the dollars that they would put on that might change your view as to whether or not you can afford to do the harder work of doing the implementation. Similarly, the work that needs to be done in documentation, in design, all of these things keep bouncing off that conceptual model. And what we see is the conceptual model being constantly in play, not just the product of the designers, the conceptual design, but actually the product of everybody who has something to say about it. So let's do a little exercise. What we want to do is just quickly go through what is the conceptual model for a personal calendar. What I'm going to do is stop this and...
You'll have to bring that over to this window.
yeah, I will.
Okay. You know how to do it.
I think I do, but we'll see what happens. Yeah, how about that? Okay, Jeff, you want to drive?
Sorry?
Just ask folk about...
Okay, so what we're going to do is a little exercise. We're going to come up with the objects, attributes, and operations for a personal calendar. So I want you to come up with ideas, and Austin's going to put them in this table. And we might have some discussion. I don't know how much time we'll have for discussion about this, but because we do have other topics we're going to cover after this brief exercise. We'll probably take 15 minutes for this.
You going to run around, Nancy?
I'm happy to run around.
Well, if
We want to
people yell them out, what
record,
we'll do is echo them aloud. How's
or
that?
you can
Okay.
repeat,
Yeah.
yes.
So give us some objects for a personal calendar. What are some of the objects? So,
Events.
Event. Sorry?
One-time
Okay, so
event.
are those different objects or are those the same object?
So different objects. Different objects because they're different types.
So what he said was that recurring is an attribute of event.
Right, exactly. I was going to just stick it that way. Okay.
So recurring or not, okay, is that right?
Yep.
A date is
I heard
what?
people.
Right,
I
yeah, so
heard-
date is an object. Is that an attribute of something? A day.
A
A
day.
day is an object. Yeah, so what you're saying is, you know, these cells can expand, so you can just write everything in the same cell.
Okay.
You don't know what I'm saying is, like, no.
I know.
Okay.
But here, the suggestion was that, right? Okay.
Yeah, so let's
now,
let's-
Austin,
let's-
you
let's
just-
talk about events.
You just said that and this, and so the audience who's listening can't hear.
Okay, so let's concentrate on events for the moment. So we have events. So we have recurring or non-recurring, and we have a date. And somebody said time, right? Okay, so that date and time.
Duration.
And somebody said location.
Location. Okay. What can you do to an event? You can create it or delete it. It's
And
telling
what
you,
would,
create.
oh, well. We got good spelling correctors out there.
Okay, so edit. How do you know? Can you view it? Can you see it? Is viewing an operation? No. Well, some people are shaking their heads and some other people are nodding their heads.
Well, you can click on it, but that's about presentation. So what is clicking on it about?
So you can,
You can see it?
you can show details.
It's called CRUD, create, read, update, delete.
Yeah, yeah, view, read, update, delete. Okay.
All right.
You're talking something like a calendar or a view.
Ah, okay.
So that's going to be. So actually, I want to ask another question about event. Are there different kinds of events, and are those different objects, or are different kinds of events an attribute on objects? Sorry. Okay, so so there's going to be a privacy attribute, but that's not what I was asking. So, but that's correct. I mean, I'm not going to say correct or wrong because different companies will come up with different models for the same application depending on the needs of their customers, right? Okay, so, but I wanted to know, are there, like, for example, is a meeting different from a birthday? If I have two events and one of them is a birthday and one's a meeting, is that a different thing, or is it just the same thing with different attribute settings?
I think your decision, it could go either way, depending on your decision as to whether these different events have the same operations. If you want to have unique operations for certain events, then that's not an attribute of the event, it becomes a new object.
Okay, so what he said is an important insight which I want to spread around the room, which is whether you make subtypes separate objects that are sort of sub-objects of the object, like checking account and bank account, and then checking account is a subtype of that, depends on whether you think that those things have different attributes and operations. And if you think that they have more or less the same operations and attributes, then it makes sense for you to make them one object with an attribute setting like type. And the type could be things like birthday, meeting, doctor's appointment, classroom, class. Whereas if you decide that they really do have different operations and attributes, then you would make them different objects. Okay?
So, this raises the question of how do you make something simple? Do you make it simple by reducing the number of kinds of objects, or by reducing the number of attributes that the objects have?
Yes.
But what you just described was a trade-off.
Yes,
It
it's a
is.
trade-off. And so, one of the things that, well, for example, we talked at the beginning about the Xerox STAR retrospective and how BayCHI got started. One of the things that the STAR had was basically 5 operations, which were create, delete, edit, read, and link. And what those, you did those in certain ways. The way you rename, there was no rename operation. If you wanted to rename a file, what you were doing was editing its name attribute. Okay? And if you wanted to delete a file, you were moving it to the trash can. Okay? And so people who came to the STAR from Unix were going, where's the rename command? Well, there isn't the rename command. There's just edit the file name. Okay, okay.
The only thing I wanted to add to this was just flag this business of day, which someone raised. We'll come back to it. But yes. Okay? Yeah. This is a very common thing to see appear when people start thinking about calendars, is their days and their hours and their times. Are those concepts of the calendar, or is there something else? We'll come back to that in a moment.
You have 2 pending questions. Can you
Go.
take them?
Hi there. Your answer to the question, or maybe it was just the question about should something be an attribute or a subtype, I think that was sort of getting ahead of things. we have to ask, what is the user's conception of what's going on? This is the user's conceptual model. So if we're talking about a personal calendar for me, I don't see a difference on my phone between a birthday and a meeting. But if my job is to schedule a ballroom, then for me those are very different things.
Right.
So don't think about whether something should be an attribute or a subtype before you ask the question, what is the user's mental model of what's going on?
Correct. So some people have asked me, where do these objects, attributes, and operations come from? And what we do, and my consulting company does, is we go out and do what Karen Holzblatt calls contextual inquiry. And we talk to people and we watch them in their workplaces, and we build up the objects, actions, objects, operations, and attributes model. And then we might have to actually modify it a little bit because we're simplifying the world down from what, the work practices that we might see in the office, or maybe we're streamlining the work processes that we see in the office, or things like that. So it's not going to always be a one-to-one correspondence, but it will be heavily informed by the user's way of carving up the world.
Yeah, and that mapping that we were talking about, the plan from the task space into these operations define or help you define what are the pieces, what are the concepts that you need. Those of you who've seen Indy Young's book, he's an elaborate work to figure out what are the different tasks and how can you map them into a smaller collection of operations. If you get them too small, then it gets too fine-grained. And so it's that trade back and forth, driven by the task. Go.
Yeah, I have a comment about the notion of simplicity. And while certainly simplicity is a nice goal, it's not the end goal. That is, you need to balance simplicity with what is needed in the application to deliver the functionality that is needed by the users. And if the users are in a complex world with a complex workflow, then relatively speaking, it's going to end up being a complex application. Now, you still want to go for simplicity by trying to pare down to the essential core of functions and objects that are needed. But that essential core could be vast or it could be very, very small. It depends on the environment you're playing to. And of course, that gets back to the notion of doing user research and contextual analysis, et cetera.
Exactly.
But people often say, oh, no, that's not simple. We don't want to do that. Well, maybe you're not in a simple environment.
And you may not only be in one environment. There may
And you may
be
not be in one
lots of
environment,
different
exactly.
effective applications which have to play together.
Right.
I was just going to say, I think that's one way to make decision of, is non-recurring an attribute of event?
Yep.
Or do you want two kinds of events? If it's in a simple environment where you don't really need that much complexity around recurrence, okay, make it one object with a recurrence attribute. But if it's scheduling the facilities of a hospital, you're probably going to want many kinds of events.
Yep.
Because that actually results in the simpler you are for them.
Right, and there's different kinds of simplicity as well. And even if you're going for simplicity, there's simplicity, for example, you can keep the number of concepts down to a bare minimum, but then you have the problem of lack of efficiency in doing certain tasks. So, for example, one example I like to give in some of my classes on user interface design is consider a word processor in which you have a blank page, and up above you have a palette of all the letters in the alphabet. And you can just drag them into place. Really simple. It'll take you 10 seconds to learn how to use it. It's not going to be very efficient for doing anything, okay? Because you didn't understand what the tasks were that people were going to be doing with it. You were just trying to make it easy to learn, which is not easy to use.
So let me say that what we're doing, obviously, is we dive down into the business of doing it. And this is exactly the conversation that the teams need to have, and what we're advocating teams have, is this struggle. What we're trying to do is put it on the table such that it is out there in the open and you can actually work on it. Let's take one more question, and then I'm going to wrap through a little bit more, and then we can come back to some more questions. Thank you.
Yeah, I was curious about designing conceptual models. On the productivity side, where there's a known task domain, it's easier, but if you're on the game side or where engagement, entertainment, or where the design is actually in an area that's not existing yet, how do you do that?
Well, there's two different things I hear there. One is the question of whether it's new and you're designing for something that you haven't built something for before. And the second one, when you mention games, pulls up for me a different thing. That the goal of a game is not necessarily such that you can figure it out instantly. It's to, in fact, hide some of that stuff. That's the fun of the game. So let's pull those two things apart and recognize that the tasks and what you want to have happen are different in those two. With respect to the business of getting to a workable conceptual model in a space where you haven't done it before at all, there are sort of two directions that I tend to jump. One is build something, prototype something really quickly and watch what happens. Second, though, is look to see what other activity that does exist, that may or may not have technological support, has what feels to you like a similar conceptual model. And then go out and study the heck out of that conceptual model already in play and see what's squeaking. See what works, see what doesn't.
Yeah, doing this, it seemed that the productivity model was less agile when you're doing a game. It really is sort of an agile building of the conceptual model just because of what you said. Put it out there, try it, keep changing it. So the model's building agilely also.
Which is
Thank
how
you.
this institution's, at least computer science departments, got founded. And Xerox, what they did was they built some of the first windowing systems, mouse systems, and they just sort of built them for themselves. And then they learned all the stuff that worked and didn't work. And then eventually they were able to build a conceptual model for the thing. And now we have the benefit of that.
All right, so let me go on quickly and say a little bit more. Can I have that, Jeff? Thank you. And then we'll come back and ask, we can take some more questions. Whoops, I got to get back to the slides here.
So just get out of Word.
Thank you, Jeff. Sure, why not? Take this and drag it which way? This way. There we go.
No.
No?
No, you're going to view.
Just hit it. Okay.
View. Yeah.
Yay. All right. So this was to the design that we were beginning to do. Here are a couple of sets of solutions that have been done in previous times. You can see this sort of thing, and then you can see this where events have gotten broken out so that you have subtypes of events. Different solution, again, reflecting some of the things that we were just talking about. Chapters 6 and 7 of the book talk about a whole collection of additional questions and suggest some of the, at least the problems and sometimes some of the solutions. The thing that, for instance, if we think about the calendaring, you have to do just doing the objects operations analysis. Doing that takes time, as Jeff said. Consider, and you've already raised it, the business of repeating events. That increases the complexity of the things, needs to get dealt with. I'm just giving some examples. In terms of supporting learning, can you use a small part of it and then can have a more elaborate part of it, sort of progressive disclosure, those notions of two different models, and one is a subset of another, and how does it work such that you can lead a person into it. The question of the conceptual model versus the presentation. This is the business of days, weeks, and months that we were talking about before. The way I think about, and we can argue about it, days, weeks, and months with respect to calendars those are something about filtering how much you're seeing, right? And so that the day is not an object in its own right, it's actually an attribute of the filter which says, what am I seeing? Okay, now there are lots of ways of carving it, but that's one in which the fact of what you're seeing is something you say, well, no, wait a minute, that's about the presentation, right? And we said you weren't supposed to do that in the conceptual model. But the filtering of ideas is part of the conceptual model, and you might choose to show that in lots of different ways.
And that's, Austin and I will sometimes call that scope.
That's right.
It's the scope. So day, week, and month, when we're talking about conceptual model, we'll often talk about scope rather than view, because view is getting into user interface stuff.
So another area of, and each one of these has a whole collection of things, I'm giving examples, is just object identity. We take it that it's not complex about what the events are, except of course if you're syncing across machines and the issue of which event is which and all of those kinds of things. We all live with those things as users. What is the model? How are we supporting it? Those are the kinds of things you have to deal with. Chapter 7 is sort of looking at more advanced topics, in particular going meta. That is, in which the activities, the operations, and the doing of those becomes some of the object itself. So this is, for instance, your history. If you want to undo, what are you undoing? The things that you are undoing, the user needs to know about those things. Those are objects about the usage of this thing, about the activity of using it. So going meta often makes life more complex. And then finally, the more we build applications which are in the hands of the users, the more we begin to enable them to add things to the application itself. So user-defined events, adding things to that. How do you enable users to grow the thing and blow it up? It's an area which has always interested me, is how do you let the users build their ontology into the system. But you start playing that game, and this thing gets complicated. And this was the comment that you were making earlier. Conceptual models do get complex, or can get complex, at least for us in thinking it through. It ain't easy. That's why 2 or 3 or many, many months as continuing work has to be done. These are just some of the ideas that have come out in some of the exercises we do. We sort of say to people, pick one of these and go at it, and sort of dig down as we were just doing. A final area that we haven't dealt with here at all, except indirectly, is notation. That is to say, how, if you're going to have all these people talking to each other, how are you going to write this stuff down? All right. Well, you've seen Jeff talking about these stories. There's a conceptual, these scenarios. That's one way of writing down, and it begins to show. It's actually a good way of introducing a conceptual model. Let you walk you through it, and this was something that Hugh Dubberly, those of you who know him up in San Francisco, one of the things he did is begin to color code the objects, the attributes, and the relationships in a story. You've seen this, which is what we've been doing here, just build a table of those things. UML, of course, has this built in deeply into the way it encourages people to think about the conceptual model. Entity relationship diagrams. This was after a picture from long ago by John Meads. Here, focusing on the relationships, mostly, right, between things. And Hugh Dubberly has done a similar sort of thing. If you haven't seen his wonderful diagrams, what he calls conceptual maps, showing this was the, again, this is sort of technology-based, but showing the conceptual objects of Java. And he has many more if you go to his website. They're really quite a lot of fun. And then various different forms that you can use to try to capture this so that you can see it, showing the objects, the attributes, the operations, and the relations. But the real story about technology, about notation, I think, is primarily pick one. Although many will argue, no, you need a number because different things do different things for different people. But really, pick one and stick with it, and give people a common language to argue about. This is, depending upon your context, different ones of these are going to be more attractive to you. You're really trying to do is get clarity, and then for efficiency, get something that you can manipulate, and whatever tools you're using, so that you can try these and compare to many descriptions that you can then put up and argue about. This becomes a crucial part of doing the work. Instead of just flailing around, being very specific. Wait a minute, can I have more than one of those? Yes, Jeff?
So I'll just comment that, for example, you might be tempted to pick UML because UML has the advantages. If you code your conceptual model in UML, then there are tools that allow you to just turn a crank and you get a stubbed out object implementation that you can then start coding against. But the question is, are the tech writers on your team who have to write manuals describing this thing going to be able to read the UML and give you, write the manuals based on it? Do they know how to read UML? So there are trade-offs.
So again, to come back to this slide, we think, conceptual model is an early step, early and continuously through the design process. Make sure that everybody has a seat at the table so that you can coordinate, so that you can test it, and then take those things and test it in the real world, see how it works, and then iterate. This is the idealized picture of what we would like to see happen. And as Jeff had walked through before, here are some of the benefits of using these things, particularly getting down to the point where you actually save time as a result of doing this other additional work, because you prevent yourself from writing stuff you don't need to write. The one other comment that I'll make as a benefit, and this is something which has been reiterated many times, but for me strongly from Hugh Dubberly, is that getting a conceptual model, particularly of something that already exists, of legacy products, of something that you're already shipping, which you don't have a conceptual model for, and then you try to do it, turns out to be some of the most bloody and effective conversations that happen to the design team. Because what happens is it pulls out of the woodwork all of the disagreements about what the conceptual model is. And so a very important part of this business of going on around the loop is starting where you don't even have a loop yet. And what you're doing is you build a conceptual model which then floats all of these difficulties to the top. I mean, I remember very clearly in doing that when I was working for Pitney Bowes, where there was a deep disagreement between two views of the way of something worked, and they were having a terrible time writing the code, and I knew why. Right? So that business of those conversations, that conceptual models as a basis for negotiation and struggle, is probably its most powerful advantage. A few selected references, and thank you.
So before we go into questions, I'll just say one thing, which is I often,
That's yours, okay.
unless you want
No.
my germs. It's sometimes a struggle to convince management to give you the time that you need to do a conceptual model. So I find that I often do them on the stealth because they'll help me even if they don't help anybody else. But that's really not the main benefit, because the main benefit is you want it out there on the table for everyone who's on the team to be bouncing off of, as Austin put it. And then the corollary to that is that even teams that begrudgingly allow us as user interface designers to build a conceptual model first might say, fine, do it. Okay, now that's done, let's go on and do the rest of it. And the conceptual model document then goes off and gathers dust on a shelf. That's exactly wrong, right? Because as Austin pointed out, you're not going to get it right the first time, the second time, or even the third time. The conceptual model has to continue to change as your understanding of the application and the task domain changes, and your understanding will change, right? That's the whole basis of Agile, is that you don't know things, you don't understand the task domain when you start a project, so don't try to spec it all out in advance. So, and in many teams that I've been involved with, the problem is if the conceptual model gets treated as a document to do at the beginning and then sort of move forward from there and abandon that document, at the end, you'll have an application coded that doesn't match the conceptual model document, and then how's the tech writer going to use the conceptual document to write the manual?
Or QA or anybody else, right?
Yeah, or QA or anybody, yeah. Trainers, whatever.
Support desk.
So now questions. Questions? Okay, we have a question down here. Wait.
So you seem to be proposing conceptual models as a way to achieve consensus among stakeholders about what we're building and why.
To build, consensus.
Okay.
And also understanding.
But it's also, I mean, in fairness, it's not everything. It doesn't say what the user interface is. It doesn't say how we're going to implement it. It doesn't say what documentation we're going to. There are a lot of things it doesn't say. But around this piece, which we think is critical to all of those, we are hoping that it will build consensus.
So who are the stakeholders? Can you name them? Okay, there's the tech writers, the interaction designers, the marketing.
The usability testers.
Usability testers. Yeah.
So here's an example.
Management.
Management,
Let me give you a
exactly.
quick example. Remember, we talked about the conceptual level scenarios. The conceptual level scenarios describe the goals of a task and the operations at a conceptual level. They do not describe the task at any kind of user interface level. So you can actually give those scenarios to users in usability tests, and you've told them what task you want them to do without telling them how to do it using the application you've just put in front of them. And so those conceptual level scenarios are very useful in usability testing.
So as a developer that's been working on many teams over the last 16 years or so, the teams that I've been on that do this, the development is maybe about a third to a half of the time that it is otherwise. Because what's often happening without this is that you tell the software developers to go build something, and that's part of the process of trying to help people understand what it is that they're asking for. And certainly there's always a part of that with Agile, but if they just take a little bit of time beforehand to figure out what are we building, then the developers go at a much faster speed when they understand what they're being asked to do.
Good, thank you.
And I'll just while we're waiting for him to get the mic, I'll just say, in Agile, they say there's no big upfront design, but there is, a cycle zero. And then that cycle zero, a lot of this architecture, this is architecture, is really what it is. It's information architecture. That's what gets done in that cycle. And actually, the way I think about it is you can actually iterate your conceptual model by trying it out on users with maybe storyboards or whatever, before you get to the point of prototyping or writing any code. And I think of it as you are actually writing code. It just the code happens to be in the form of tables or in storyboards.
But it has the property that code has of being crisp.
Of being crisp.
And therefore being disprovable.
And testable.
Yeah.
Yeah, I wanted to, first agree with the previous comment up the hallway there, and say that the inverse of what he was saying is also true, and that is most design is redesign, is designing something that's already in existence and trying to improve on it, in which case you're often limited by what code is already there. You mentioned legacy before. Yep. If you create a good conceptual model, present that to the developers, you already know what code's there. They can come back and say, well, actually, this is not a type of that. These are two different complete things, or this is an attribute of that. And suddenly you can get a sense, even if you're not a developer, but if you are a developer, you can get a better sense of what's in the code that can enable a better discussion with the developers, so you're designing something that they can actually do.
Yep.
And you can understand what works and what doesn't work ahead of time.
And in the same way Jeff was talking about once you get something and then you go off and build it and let this drift, now you sort of say, okay, well, now we're going to make a change to this. And you come and you look at your code, but the code doesn't match what the story was. So you get these surprises. One of the things that's always encouraged, and again, coming back to the table, is if you're going to, often you'll do a fix to get some user interface or some conceptual change in. You don't actually change the code to reflect it, right? So now you're on borrowed time, because if you then say, I'm going to go on beyond that, now you're going 2 steps on top of this. So the doing the backfilling of making your code reflect your conceptual model, even if you do a fix, but then correct it such that you could then move on, is sort of good, just good hygiene. Yeah.
And if you see a huge gap between your conceptual model and what the engineers have in their actual UML, that gives us a heads up. There's could be some serious recoding to be done.
Either that
Or
rethinking of the conceptual model, because if it's actually working better that way, maybe we can take advantage of it.
A couple more questions.
Sure.
Yes, I wondered if you could make some comments about how you deal with onboarding people that are coming in later in the process, such as a writer who comes in, looks at your terminology and just thinks it's their job to change all that was just there as a suggestion, or they don't even look at it or read it.
Well, what I would say is, when you onboard people who are coming in toward the end or in the middle of the process, you have to tell them what the process is, and that the team came up with this understanding via a long process, and it's not anyone's right to change things on their own. It's the same thing for a tech writer as it is for a programmer. The programmer doesn't get to add concepts to the conceptual model because they want to, or because of convenience. They have, their job is to implement the conceptual model.
But the flip side of it is, in implementing or in writing, you may get some ahas about how the conceptual model could be better, or maybe even how the terminology would somehow or other reflect a change in the concepts.
Then you go back to the team.
That then becomes back to the table, not that's my job. So to the extent that you hire someone to go in, who thinks that their job is to change it all alone, then you've got a problem on your hands.
Now, somebody asked a question earlier that I want to address, or at least it was brought up before even we got to the questions, which is legacy systems. That is, we're often we're not in the process of designing new software all the time. We're sometimes building software that's built on top of old software. So for example, Obamacare, right, the websites. One of the big problems with them is that the legacy systems the databases and other back-end systems that they were building this on, all these websites on, didn't match the conceptual model, because no one thought of the conceptual model that they were going to need for signing up millions of people for healthcare when they built these, databases, 25 years ago. So that's why Austin was saying it's often a good exercise to go back and look at your legacy systems that you're basing your implementation on and develop their conceptual model. Especially when systems have to interact. I mean, one of the things that's in our book and buried in one of the chapters somewhere, and Austin could talk about this and make more sense of it than I can, but often the conceptual model of different modules of the thing which have been implemented separately have to be made to match, right? Microsoft Office, for example. There are different conceptual models there in Word and Excel and Outlook and the other tools, but they've kind of tried to bring them together to a certain extent over time, and they've had some successes and some non-successes. But the whole point is that those conceptual models have to match at least well enough for you to be able to transfer information from one of those applications to another.
So the larger comment there is you're rarely designing something just sort of on its own. You're almost always designing in the midst of either existing stuff or a whole collection of applications, which this has to fit in with, or a grand plan for where you're going down the road. That makes a complex problem often much more complex, but it also often raises powerful ways of restricting and limiting what the decision. Yes, we could do something like that, but that won't work for this other stuff. Let's not. Let's leave that in the user domain.
Any other questions?
So again, thinking of legacy software that may not have an object model documented yet, and you're trying to add new functionality to it, do you use the terms in the current product that customers have been using, especially if these are sort of like abstract concepts like programming development, like program development? So that the program may have very abstract constructs in it that you wouldn't see in a real world. Do you use those terms, or do you try to, as you go forward, or do you try to take it up a level to more abstract concepts than what are existing in the existing program?
I'll just say quickly, it depends on your corporate goal. If your company goal is to keep your application focused on those same users and to make them more efficient, then you have to kind of stay focused on the way they see the world. But often that's not a company goal. Often a company goal is to take the pyramid of users and go down that pyramid and get to the large body, very large body of users that you've never been able to touch. And if you're going to do that, then you need to go back to basics and say, how is this application domain actually structured in the bulk of the user's minds?
And the one other thing that I would say about that, while strongly supporting Jeff's one word, one concept, different words, different concepts, it's a choice that you make as you deploy applications into different contexts, that you may choose to say, listen, in this context, these things, which are now become abstract internal team ideas, are expressed, they use different words for those things.
Yeah.
And then what you have to do is you put in a layer of mapping between the at least the naming of those concepts in the local in the local circumstance from the ones which are the common terms inside your team. That's tricky. Watch what you do and make sure that you do it completely, so you don't mix those two things up.
I once designed a software for a company that was supplying software to the insurance industry. Okay, and it turns out that insurance company one calls when someone has an accident in their car and they file the paperwork, that's called a claim. And another insurance company, that's called a loss. Right? And so we had to make the software so that they could localize it for one company A versus company B, not for England versus Japan.
But when you make that move, that's usually something that you're doing in the user interface. But you need to be really clear that that's what you're doing, and you use the common central set of terms and then a mapping to the other ones. If you try to mush them together, you get losses and claims all mushed together and you get a mess.
Thank you.
So any further questions? Okay, thank you.
Thank you very much.